Hello. This lecture I will talk about the bearing capacity of shallow foundations, and an Excel spreadsheet will provide in the description section. I will show how to use the spreadsheet to calculate the bearing capacity. First, shallow foundation failure are two main characteristics. They are soil shear failures and undergo excessive settlement. In this lecture, I am focusing on soil shear failure. There are three types of soil failure, which depend on the soil type. 4. Dense sand. A general failure occurs which produces a fully developed failure plane. It has a sudden or catastrophic failure, and bulges on the ground surface adjacent to the foundation. 4. Sand or clay with medium compaction. Local shear failure occurs when the failure plane is not completely defined. It will have sudden jerks at failure. 4. Very loose sand or weak clay. Punching shear failure may occur, and footing foundation may sink into soil like a punch. This figure shows the relationship between loading, unit area versus settlement. We can obtain the ultimate bearing pressure quote. Bearing pressure is the contact force per unit area along the bottom of the foundation. The ultimate bearing capacity is the gross pressure at the base of the foundation at which soil fail and shear. Net increase in pressure at the base foundation or structural load that causes shear failure of the soil is net ultimate bearing capacity. The net ultimate bearing capacity is ultimate bearing capacity minus overburden pressure, which the overburden pressure is the effective overburden pressure at the base of the foundation. It means it is the soil effective unit weight times the depth of the soil that originally exists above the base of the foundation. 4. Allowable bearing capacity. A safety factor needs to be applied. The FOS mostly taken as 2-3. The allowable bearing capacity is the maximum pressure which the soil can carry safety, without undergoing shear failure and excessive settlement. Now, I will talk about Terzaghi theory, which developed in 1943. The formula consists of 3 parts. The first part is shear strength of soil, which is depend on soil cohesion and angle of shear resistance. The second part of this formula is surcharge, which is overburden pressure in the ground adjacent to the foundation, and at same level as the base of the foundation. The third part of the formula is soil self-weight, which is depend on angle of shear resistance and weight of soil. After considering shape factor, inclination factor, bearing capacity factor, tilt factor and ground sloping factor. The general form of this formula is here, and here shows the calculation of different kinds of factors. Don't worry, an Excel spreadsheet will be provided. In this lecture, I will only talk about level ground, which means the frontal slope angle is 0. 4. Foundation with eccentricity moment, shear force, and slope angle not equal to 0. I will talk in the next video. So, please subscribe to this channel. Thank you very much. In this example, I am going to design the required area of foundation. The soil with density 16.5 kN per meter cube in dry condition, and 18.55 kN per meter cube in saturated condition. The friction angle is 35 degrees, and the depth of foundation is 122 m below the ground. The water level is 0.61 m below the ground. The footing required to take 667.2 kN loading with factor of safety equals 3. We now open the Excel spreadsheet. I provided in the description. If it can give you some help, you can download it and remember to subscribe to my channel. I will provide more information and spreadsheets in my future videos. In this example, I first try using 1m x 1m. In B, type 1 and L type 1. In this case, the vertical force is 667.2 kN. Without any moment, type 667.2 and 0 for moment. Then, it shows that E equals 0, which means this footing doesn't have any eccentricity along B. Here we can calculate the force per unit area, which is 667 kN. Then we input soil property. Cohesion equals 0. Friction angle equal 35 degrees. Soil density equals 16.5 kN per meter cube. Saturated soil density equal 18.55 kN per meter cube. Angle of foundation base and slope in front of foundation equals 0. For a more complicated case, I will talk in my next lecture. Please subscribe to my channel. In this example, the foundation base to ground level, which mean the depth of foundation dr, is equal to 122 m, and the water level is 0.61 m below the ground. Which mean the effective soil weight above footing is 16.5 times 0.61 plus 18.5 minus 9.81 times 0.61, which equal to 15.4 kN per meter square. Here, we can obtain the ultimate bearing capacity, and the FOS is less than 3. Now, I need to enlarge the footing size. I try 1.5 m beneath and 1.5 m long. Type 1.5 in here and here. Go to the bottom of the spreadsheet. FOS equals 3.5, which is larger than 3. It means the size of the foundation 1.5 m x 1.5 m is required to provide a satisfactory factor of safety. Thank you. Hope this video can give you some help. And remember to subscribe to my channel. I will provide a more complicated example on calculating bearing capacity with eccentricity and slope base in the next video. Please subscribe to my channel. Thank you for watching.